All right, let's get started with our introduction to differential equations. Okay, so you can write it on here. I have this blank here. I'm just going to write it off to the side because it helps me stay organized when I have these lines. Okay, so up to this point in a lot of our studies, we've been able to solve different type of algebraic expressions, right? Whether they be quadratic, polynomial, radical, rational, so on and so forth, right? So again, up to this point, we've been able to solve equations that look like this, right? Maybe a quadratic, right? X squared plus 7x plus 10 equals 0. We would factor this, right? X plus 5x plus 2 equals 0, and then we can skip down or do all the work and say that x equals negative 5 or x equals negative 2, right? And again, a lot of these algebraic expressions have been a set of numbers or a number, right? Um, we've been able to identify it as such. In differential equations, essentially our answers are now going to be equations. Okay, so for example, when I showed you an example of an algebraic expression, right? Let's look at one that is a differential equation, right? We can look at an example like y double prime plus 2y prime equals 3y. Okay, so in this scenario, right, and again, going back to the algebraic, right, there was an x that satisfied this equation, right? Well, in the differential equation, well, there's an equation y, right, y of x, that when I take the second derivative and plug it in and add it to 2 times the first derivative, it would equal 3 times, this equation, 3 times the equation that we find, right? And again, we're going to spend this entire semester, right, trying to solve these type of equations, right? And just so that we're all on the same page, right, there's different ways of viewing this equation. Just to recall, right, we can use also function notation, right? F, again, that's my weird looking f double prime plus 2 times f prime equals 3f, right? Again, using function notation. And then if I were using Lebanese notation, would be the second derivative with respect to x plus 2 times the first derivative with respect to x equals 3y. Right? Again, just recalling, these are all equivalent. These are all, ways that it can appear to us on the book, or it can appear to us as a question, right, to solve this differential equation. Okay, and again, just so that we can get a flavor of this, right, the solution to this equation would be y equals e to the negative 3x power. Okay, and again, we're going to spend a bunch of time this semester learning how to get this solution, right? We're just kind of getting a flavor of this. So again, if I were to take the first derivative of this, it would be negative 3e to 3x. If I took the second derivative, it would be positive. And again, let's just plug it in, and we see that this will satisfy. Okay, so if we put this in, we got 9e negative 3x plus 2 times negative 3e 3x equals 3 times e to negative 3x. Filling this out, simplifying, minus 6e 3x equals 3x. And because these are like terms, we can do this. And what do you know? It does check out. All right. So again, that's just a quick introduction into what differential equations look like, what the solutions look like, and kind of the key differences between what we've been doing to what we're going to be doing. Right.